In this video, we're going to look at step graphs. Step graphs really are kind of an easy concept to think about because they simply look like steps. They also don't show gradual changes. In fact, they occur. They show jumps. They show changes that occur in steps. And we might be familiar with broken line graphs, which we've learned previously, which show gradual changes. Let's go ahead and take a look at a step graph. It says the graph below is called a step graph. It shows the cost of sending a letter weighing 1 ounce or less by first-class mail anywhere in the United States. And you guys might be very familiar with 1 ounce. 1 ounce really just weighs about the size of one jumbo-sized paper clip. Step graphs are great because they often show a change along the horizontal line axis where there's time. And you'll notice that in this graph, our horizontal axis represents time. It's also great when it shows distance as well, but this one shows time along the horizontal axis. You'll notice that in this step graph, it's showing over here on the left-hand side, on the vertical axis, it's showing you the cost in postage, how much it's going to cost you to send something. And these dots with a long line shows you that the cost is being consistent over that time period, And the height of each step shows the cost. Okay, so if we're jumping to a new step, that's showing you a change in cost, a change in that vertical axis that we talked about. You guys might be surprised to find, I know that this only goes back to 1905, but a strange little fact is that actually to send a letter over 400 miles in 1799 was only 31 cents. Which actually is a lot higher than you'll see the 3 cents that we're starting out at in 1905. Similarly, in 1815, it reached as high as 44 cents to send a piece of postage. So prices of postage haven't always been very low. Notice these dots next to each step, and notice that actually includes the value right below it. So you'll see that it looks like this line ends right where this dot begins. What is the price at this point right here? It's actually where that dot exists. So again, if we look really closely and we say, hey, this line ends and this new step and line begins here, which one are we looking at this year? We're going to look right at that dot. That dot says to include that and go at that price. Okay, along the vertical axis. To kind of clarify here, this portion of the number line says that we're including 1 and we're including 8. Okay, so we're including 1, including 8. That's a closed line. In math, when we have an open line, for instance, down here, we're saying we're looking at all of the numbers very close to -2. But not actually -2. So for instance, -1 and 99/100 is very close to -2, but it does not include it. Similarly, over here, we're saying we're looking at all of the values up to 3, but not including 3. So we might be looking at 3 and 9/10, right? 3 and 9/10. Moving forward, let's go ahead and answer a couple of questions about this to gain some familiarity with step graphs. The cost of mailing a letter was 3 cents from 1932 until when? 1932 until when? If we go back to our step graph, we find 1932. Here's 1935. And we're going to go back 1934, 1933, 1932, and we see a dot beginning right there. How long does it continue for? When does it stop being 3 cents? Well, here's 1955, 1956, 1957, 1958. So we see a change in 1958. Another great opportunity to practice our step graph skills will be looking at a taxi cab ride service. You'll notice below that the second that you get inside of a taxi cab, the second that you travel 1 foot, it's going to cost you $2. And it's going to cost you $2 until you get to 1 mile. And the second that you pass 1 mile, it's going to jump up. The price that you're going to have to pay is going to jump up just when you go just past a mile. And it's going to jump up to $4 until you get to 2 miles. All right? And if we look up here, okay, when we go, when we go more than 2 miles, not more than 3, that's going to make us jump up to $5. So right when we pass 2 miles, we're going to have to make another jump. But you might say, Mr. Heck, there is no $5 mark on the vertical axis. Well, we've got 4, we've got 6, 5 would be right in between it. So we start our line right here until we get to 3 miles. And when we go more than 3 miles, but not more than 5, we're going to make another jump up to 6. So we're going to jump up, make a line, and a big dot. And you'll notice that, okay, Mr. Heck, what happens if I traveled exactly 3 miles? Well, if you traveled exactly 3 miles, we're going to look for that dot. We're going to look for this dot that was created on the edge of our at the edge of our $5 cost. And as we kind of go across, we'll see, okay, that is going to be $5. Let's go ahead and take a look at a couple other examples. For instance, what would it cost to go 3 7/10 of a mile? Well, if we were going 3 7/10 of a mile, we would want to go just past 3.5, maybe to 3 7/10, and we would go up and we say, what's the cost going to be? Well, it runs right into this step on our graph, which is going to go ahead and correlate with that $6 charge along the vertical axis. So it's going to cost us $6. Okay? The reason why these graphs are so great to use is that oftentimes it wouldn't be appropriate and it might be misleading to use, for instance, a broken line graph. You might consider that there's a broken line. If there were a broken line graph, you might assume that there is a gradual increase from, for instance, 1985 until this new price increase, which occurred in 1988. Instead, at the end of 1988, we saw an immediate jump in the price of postage to 25 cents. So these show steps and jumps from step to step. Similarly, in our taxi cab example, we saw jumps. For instance, once you had traveled exactly 1 mile, if you had gone just over 1 mile, it immediately jumped up to $4, showing that they are not gradual increases, but step increases. Hopefully you're more comfortable working with step graphs. I want to wish you guys best of luck.